Hello everyone, here is the video about my project that is named Geopolitics and Commodities from Predictive Forecasting to Statistical Association. In February 2022, Russia invades Ukraine, and within days, European natural gas surges 300% and wheat jumps 50%. So the question is, can we forecast commodity volatility using geopolitical risk indices? So the problem is, while traditional models fail, they rely on historical price pattern, technical indicators, and supply-demand fundamentals. But these fail during geopolitical crises like wars, sanction, and diplomatic tension, with recent examples like the 2008 crisis, the Ukraine war, or even the COVID-19. So the solution is to use, for us, the geopolitical risk index dataset, as well as sentiment analysis via keyword extraction from a big news datasets from the Australian Broadcasting Corporation. For the technical approach, we use the two-stage research design. First stage being, can we forecast using a long short-term memory neural networks to predict 5-day rolling volatility, and a trading simulation, so a backtest with volatility-based strategies and calculating Sharpe ratios. And since that forecasting failed, stage two was, is there a relationship? And for that, we used the Gauge in mean model with the underlying question being, do geopolitical variables predict returns? The data collection architecture is quite simple. We have 6 commodities divided in 3 sectors, which are energy, metals, and agriculture. And for the data sources, the Yahoo Finance API is what we use to get daily commodity prices. The LSTM architecture. So why LSTM first? Because it captures long-range dependencies via gating mechanism. And it also captures non-linear patterns that linear models could miss, and that actually missed in our model since the classic test failed, such as random forest, as well as linear regression, for example. For the Gauge framework and the statistical hypothesis testing, since the LSTM forecasting failed, we went into a second stage being, is there any statistical relationship? We tested for that four model, so the baseline gauge and the gauge with each geopolitical indices. We also did tests like likelihood ratios and coefficient p-values. Now, for the code demonstration, I'm going to show you my screen. First, I'm going to run right now the data collection part. So what it does, it downloads 6 commodities from the Yahoo Finance API, merges them with the geopolitical index, and extract geopolitical keywords from the news headline, with the keywords being the one you see here. So it's a big list using every word that could relate to a geopolitical event. And at the end, it creates CSV file for each commodities. Second is the exploratory data analysis that I'm going to run right now. This exploratory data analysis is actually used to get charts like the correlation chart that you can see here. This these features actually finds correlation between each geopolitical indices and return, volatility, return lag, and so on for each commodity. Second, it shows the volatility time series for the WTI, so oil. You can see in red 3 events, so the 2008 crisis, the COVID-19, and war in Ukraine. And you see an alignment between, in purple, the geopolitical spikes and an increase in volatility. But you also see, and mostly for the Ukraine war, that the volatility doesn't jump as hard as the geopolitical risk increases. And that is why forecasting is hard. Third, I would like to show you the LSTM model. Since it's quite long to run, I'm going to start it right now and show you the output at the end. But basically, the idea is that the LSTM training processes for each commodities the feature set, different feature set, being the baseline with only return and volatility, then one with the geopolitical risk index, then as you can see here, then one with the geo keywords, so the keywords that we extracted from the news data sets, and also another one that uses both of them and tries to forecast. Okay, so now the LSTM model is done running after around 10 minutes. And as you can see here, it runs successfully across each commodities, and we end up with, for each commodity and each feature, a negative R squared. Why is that? Well, because the model tried to predict and forecast, but it failed. And we actually do see that the model runs successfully, and we can even compare thanks to the analysis right here, the average performance by feature set that he has shown here, and for the average for each feature is gives a negative R squared, with the best one, if I could say, being the baseline one, meaning that adding the geopolitical layer doesn't help at all in the forecasting of the commodity price and based on the volatility. Also, to precise more on the code itself, so first we get the helper function, which are used to prepare the trading strategy as well as building the LSTM model, as you can see here, with the LSTM model, the smaller one that is right here, and also a bigger and denser model right here with 24 units in the LSTM. And after that, it's only function to plot results, and also the function to run the LSTM as well as the main execution right here. After running the LSTM model, so on the right one, you see the blue line that represent the actual volatility, and the red line that represent the predicted volatility. And the red line stays flat, which means that the model just predict the mean and misses all the spikes. And that problem happens for all 6 commodities. And this is mostly due to the R squared being negative and the model showing that the the statistical significance is not existent. Then for the gauge model that I'm running right now, so what it does, it tries to predict and to find if there is any statistical significance. And the key findings are that the geopolitical variable, improve the model fits, but the coefficients are tiny. So with the likelihood ratio test, we actually do see that, yeah, here, that it is highly significant, the joint variable, but individually they are not significant. I'm going now to show you the charts that prove this. So here, the likelihood ratio test. So on the left, you see that the, va- the value exceed the critical value are in red here. And on the right, you see all the p-value that are much lower than the classic p-value we look for, which are 0.05 or even lower. Now I'm showing you the statistical test. So what it does is it calculates Sharpe ratio based on the forecasted volatility, and then tries to see if there is any improvement using geopolitical indices or not. Here you see that for this wheat, copper, and lithium, those are the three commodities that are significant, and you see that the Sharpe ratio do increase for lithium, but the Sharpe ratio is much worse for wheat and copper. Now, for results and learning, so three main findings. LSTM forecasting fails. All of the models have out of sample R squared, and we see that public data cannot really beat naive baseline. Second finding is that there is a statistical significance, but it is very small, which means that it is economically trivial and absolutely impossible to use for any trading purpose. And third finding is that the huge heterogeneity across sectors, with lithium having a strong improvement of the Sharpe ratios, or copper a strong decrease in the Sharpe ratios, shows that the model is maybe too broad and that we should probably improve it. So what this teaches us, first, market efficiency remains. The geopolitical events are already priced into markets. Second, even though there is a statistical significance, it is not really usable for any trading purpose. Third, that deep learning has limits, and that LSTM, even though powerful, cannot really create information. And fourth, that sector-specific models matter, because the model ignore heterogeneity between commodities. We should definitely change it and get some sector-specific model. So how to improve? As I said, sector-specific model, but also real-time data, higher frequency, specialized features for a specific commodity, maybe some proprietary signals like shipping data, social media, real-time sentiment, or any satellite imagery for cargo ship, for example. As a conclusion, I would like to say that geopolitical risk is detectable in commodity markets statistically, but it's too weak to forecast profitably, too fast for daily models to capture, and too noisy for reliable trading signals. Markets efficiency theory remains, and yesterday news cannot systematically predict tomorrow's prices. Thank you.